Hey everybody, this is the good thing. Today we're just a little bit late. As you can see, it's not Stefan, it's just Jens. I just brought David and Sergey today to the stream. And yeah, Stefan is currently doing his marriage ceremonies, so he's off this week. And I thought this is a great opportunity to bring in some fresh new content, talk about GraphQL query planning, federation, composition, all these kind of things. With me today, I have David, our Chief Executive Worst Engineer. He's one of our masterminds behind GraphQL composition. And I have Sergey, who's been working on query planning and GraphQL engine behind Cosmo for quite some while now. Let's start with David. David, how are you doing today?
Oh, I'm very well, thank you for asking, Jens. It's a nice day. It's cold, but it's not raining, so can't complain.
Well, what have you recently been working on?
A week or two ago, we were working on configure description. That was a cool idea that came from a customer. I think we got it to a great place that allows not only that customer but everybody to have granular control over their federation descriptions. Really happy how it turned out. We have further ideas how we can add more to it, but I'm happy with how it went, and it was fun to implement and fun to have that feedback loop directly with the customer on
it. Can you give us a little bit of background on this idea with configure description? Like where did this thing come from?
Yeah, so this customer essentially wanted to have granular control over how their descriptions propagated in the supergraph. So for folks who maybe are not so familiar, you can have multiple services that have the same instance of a coordinate. So you could have query.field in one graph and then query.field in another graph, and they could each have their own description. And for whatever reason, there may be that you want to have one description in one service, which serves a function for the developers there, tells them information. It's also possible that field has a slightly different role in that graph compared to another one. And then you have another graph where you have a more of a outward client-facing description that you want to propagate. But the actual algorithm of how those descriptions get propagated into the federated graph are too naive to be able to have that kind of granular control. So this customer essentially, I believe they had like a transformer so that they could do all this with a post process, or perhaps it was like a middleman process before the composition happened to propagate what they wanted in there, or they would rely on warnings and errors that things were not lining up how they should have done. And basically we tried to streamline that process so that they can just stick a directive in. Do they want the description in the federated graph? Okay, there you go. You don't want it to be in the federated graph or anywhere that's public? Okay, there you go. You want to override what's actually in there with something else. So you have one description for your developers who are working or owning that subgraph. You have a different description for what actually is propagated. There you go. You can do all these things. And I believe for the most part, we've solved that issue quite elegantly.
Yeah, it might sound like a very minor thing. Like if you think about composition in the world of federation, I think the very last thing would be to talk about comments or descriptions. But as you scale, I think this was very interesting to see that at large scale environments, and some of our customers have a lot of graphs, like 80, 90, more than 100, and suddenly things like descriptions become a problem because you want to know like what is the source of truth and other things. So yeah, interesting stuff. And it's also great that we are in a position where we can work directly with customers, solve these issues. And yeah, on the second slot we have Sergey with us. Sergey, it's great to have you on the podcast. I think we had you on the podcast in the very beginning of when we started WunderGraph some years ago. And for those who don't know, Sergey is our first engineer. I think the first hire, so engineer number one. And yeah, maybe you can walk us a little bit through like what is your journey with me? What is your journey with WunderGraph? Because actually we're working together for quite some time, right?
Yeah, just about like 5 years or so. I consider it like a quite a long time for being on the project, and like I have a career over like probably 14 years already, and this is just my last longing product, which never ends actually, and I always have what to do, and it is very enjoyable, and I get a satisfaction from doing this job. Like it's really cool.
Yeah, I remember. So Sergey and I, we met at Tyke Technologies. It's an company headquartered in London, I think, with a remote culture, which allowed Sergey from the Ukraine and me from Germany to actually meet. And they have an open source API gateway. It's written in Go. And like many years ago, I think around 2018, I wanted to dive into the world of GraphQL and build some tooling. And I saw that there's not so much tooling for GraphQL and Go. So I created GraphQL Go tools, and I took it and went to Tyke and applied there for a job and said, hey guys, you have an API gateway in Go. I have a GraphQL library in Go. We should put it into your gateway. And then somehow I got the job. I actually created the job. That job didn't exist. And there was this guy, Sergey, in another team. And I think in the beginning you were not immediately convinced that this is the thing, or like, do you remember like the early days?
Yeah, I do, but it is not like that. Basically, it was a funny story because like I got asked by my team lead, like, do I know GraphQL? I said, of course I know it. I use it on one project, but I just didn't know into what I'm subscribing for and like what it will be. And then I started working on the first task, like and yeah, it just was whole another world, like this IST thing, like reading GraphQL spec continuously, digging into it. Yeah, and one of my commits was that I split a couple of files into plenty of files. Like Jens has a drawback that he likes to bootstrap something very quickly, and when the code grows, just the file grows, and when you have just a single file with 10,000 lines, it's just unmanageable. Yeah, so yeah, my first job was like just to split that files into smaller ones. And yeah, 5 years later, I could say that I own like 60% of a project because yeah, I don't share this currently with anyone other. Like, and yeah, I'm very into this project because yeah, I have written a lot of things, and we have created a lot of things, new things, fixed old things. We made like as much close as possible to conform with GraphQL reference implementation in JavaScript. We align it most of the validation rules. We try to be compliant. Of course, we are different because we are just not regular GraphQL library. It is not like a GraphQL gen, which is de facto a standard in Go development to build a GraphQL. It always was like something on top, and when you work on the actually GraphQL gateway, it's quite different from the API gateway or just from a regular GraphQL server, because you have like so many other like complex things and challenges which you need to accomplish and to make work. And yeah, it's really endless thing. You could improve it more. We always have new ideas, and yeah, it's quite challenging and quite interesting job.
Sergey and I, we have this internal joke that I keep bootstrapping new projects, and because I'm usually I have a lot of meetings and I'm very time constrained, so I'm typically in a hurry. So I build something like rather quickly, and I create like not files with 10,000 lines, but I don't know why I have a tendency to just add more stuff to the file, and then after a while, when it turns into a real project, then Sergey goes after my code and he rips it apart into a well-maintainable structure. So yeah, I'm like the little speedboat, and Sergey is a bit more, I don't know, he's like a gardener, or I don't know, he takes care of the chaos I created. So yeah, but yeah, it's interesting how long we're already together. And one other question I have is, like, WunderGraph, GraphQL Federation, GraphQL Go tools, the library we're working on. This is what we're doing, but the way or the constraints we're operating on, it's still that we're an early stage startup. So maybe a question to David. What is your experience so far? What is unique about working in an early stage startup? What makes it different from other jobs?
Like I'm not sure that's actually the correct question, because startups can vary quite considerably. Of course, our startup is, I would say, quite fast paced. I mean, a lot of startups are, but even then, like, we release multiple times a day. Sometimes we're releasing features and fixes and whatever else, all in just a day's work. It's great to be able to get things out to customers quickly, as opposed to having a lot of red tape and processes that prevent you from shipping things out. And of course, red tape and processes are there for the protection of the customer, but when as long as you have a good QA system and the tests in place and such, getting things out so that people can actually use them and get feedback and whatever is really valuable. And the feedback loop as well is something that. So in my first job, I worked at a financial testing software, testing financial software. So like the customers were Visa and MasterCard and things like that, banks and places. And we would often get tickets on, we used Jira then. Luckily, we don't use Jira now. No shade on Jira, but I don't like Jira. We use Linear. And we would get tickets in and said, like, oh, MasterCard have asked for such and such a thing. But the actual people talking to MasterCard were not the engineers. They were, I guess, the product owners or perhaps support teams were talking to those. And then they would have an idea of what MasterCard wanted or whoever the client was. And then you would kind of implement that feature or request. But there was one time I remember where I was actually able to ask this company, it was actually MasterCard, what is it you actually want for this? What do you want to achieve with this? And what was in the ticket with the specifications were actually a little bit different to what they actually wanted. They were trying to solve a problem, and they thought that we had to solve it one way. There was a better way to solve it. And if I was able to have that conversation directly with that customer, it would have saved, I think, a lot of time, and it would have proved for a better solution. It would have been a tailored solution. And what I really like about it, WunderGraph, is that we, as engineers, have a direct line to not only the engineers at the customers that we provide services for, but their managers and their product owners. And we directly get all the feedback, all the things that they have to say about the product, what works well, what could be improved, what doesn't work, for example. And we can get that feedback loop directly, get the feedback on the code. And it really drives you when you know what you're building is being used, and you can ask about how they're finding it, or what you could do better, or like just even the comment that, oh no, this is working great, thanks for the quick fix. It really boosts morale. I think it's perfect for the engineer involved. It's perfect for the customer involved. I couldn't imagine, if I ever were to join a different company for whatever reason, I couldn't imagine another space where I would not want to have this exact direct feedback loop with the customer. I think it's absolutely priceless, and it's one of my favorite things.
I totally agree with that. Like, I worked for quite a long time and never had like actually such speed chain of this reaction. It's really reactive, not in a React way, but yeah, totally unique way, and it's a great feeling. Like, you see, you have immediate impact, and you could bring something new very fast, and you could fix it in case there is any problems, and yeah, everyone is satisfied. Like, we as developers, our customers as our customers. Yeah, it's really unique situation, I believe, because not so many startups or libraries, whatever, have such a quick feedback. Like, we are open source, but it also like has a different situation. Like, we also have customers, and this feedback loop is awesome. And even our open source contributions, usually they take in just a bit longer to accomplish something, but yeah, people also love that we are trying to accept fixes, that we respond in, we provide guidance sometimes, and yeah, it's really unique project to work with.
Yeah, I would say, like, from a startup perspective. So this was like the engineering perspective, but from a startup perspective, sometimes, like, for example, in investors, they ask you, like, what is the moat of the company? And this is especially an interesting question when you have a lot of open source code, because now you could say, well, the code cannot be the moat, right? Because it's open source. Everybody could just take it and run their own router. Like, what is the product? And the one thing I would say to this discussion is, I think a huge part of the moat is the velocity, because yes, you can run Cosmo yourself, everybody. It's open source, but do you have the expertise and the velocity to quickly change it? And I think for a start, one of the big parts of a moat is the ability to quickly change code, and what pays into that is maintainability. And for example, one very big topic that we're currently heavily investing in is reliability. So we're currently building, for example, one tool that can preview query plans, because we came to realize that when you have very, very big customers with large deployments, and you want to work on the query planner, or you want to work on composition, or you want to change the router in some way, like, it's software, we want to change it, we want to improve it, but you never want to break something. And one super important piece of that is we want to ensure that query plans don't have regressions. So we improve query planning or composition in some way, and we want to ensure that it doesn't break anything. So one thing we're currently building, and we actually, as part of that, yesterday we released new functionality for the router. The router can now run in a headless mode, where you can feed it from the file system a schema or an execution config, but more or less it's just a schema. and you can feed operations, and then you can in a batch plan the operations. So you can see, well, how will the query plans look like, and can I plan all the queries? And then you can do this step for different versions of the router. For example, if you make a new release, you can test 2 router versions, or if you change a subgraph, you can run this process with 2 configurations, the previous configuration and now the new configuration with your new subgraph. And then we can compare the query plans. And this is like a safeguard to say, like, okay, we're a big company. We have over 1,000 queries in production. We're making a change. Will the query plans look like we expected? Because let's say you put an override directive or a provide directive or something, and you guys are the experts. Like, tell me a little bit about what happens if I use directives like provides, external, override. Like, what can it potentially do with query plans?
Yeah, like query plans itself, it's a rather big topic, and yeah, one of the good things, and I'm glad that we are inspired by Apple in that way. Like it's a visualization of query plans, like human readable version of query plan. It's very good to understand what's happening, like in what fetches you are doing, in what way you fetch in, like in parallel or in sequential way. And by using Federation directive, by the Federation nature, all these directives, they are defined behavior of the how you resolving data. And by using overrides, you basically change in the place of a field where it will be resolved. And it has a direct influence on query plan, because you constantly will move the place from where this field would be resolved. But when you use that, you have to consider that this field, it could be used in some required directive in some other subgraph, and it's required by this subgraph, for example. So you move it to another subgraph, and basically you have another chain of requests, because you need to fetch this field from totally other place. But it will be required only when you query field which has this requires configuration. And at the same time, when you for example, just put requires, it will mean that always when you request this field, you will have to request something from other subgraph. And requires doesn't make a lot of sense when you do have all data locally in a subgraph, and in Planner it will be just reflected that there will be no outside fetches. You have all data just right here. And at the same time, you have provide directive. Provide directive serves purpose of optimization the query chain, and it is actually rather hard to make it use well and to place it exactly where you need it. Most of the cases you just could see that, okay, I always need this field, and why not to make it provided? Like usually I need to fetch it from the other subgraph, but maybe my system has access to this field. So I'm placing a provide directive, and basically we will be fetching this field on this given paths and like from the root query paths or from some relative paths to the entity. We will be fetching this field like from this place now, because it is available. But not all people know that basically provides is an optional optimization. And there could be very rare situation when actually you have a provided node, but you won't fetch it from that subgraph where it was provided, because it's not beneficial to do a fetch to this subgraph, because basically all your other fields come into another subgraph, and this another subgraph also have this field, and you just don't want to fetch the field from 2 places. You just will do one single fetch. Yeah, this is like from my point of view, but also like you're working with composed graph, like federated graph, and it also has an additional meaning not only for the execution, but I think David could add more on top of that.
I have one question. If we take one step back, so there's various terms. So we have federation. Then we have something that a lot of people, they talk about composition. Then we have supergraphs. And we have in Cosmo, we have something we call execution config. And and another term we use is query planning, and then we have query execution. So maybe, I don't know, David, Sergey, maybe you can explain a little bit the ecosystem and how it all plays together, because from conversations with you two, one thing I learned is that actually query planning and composition, they are kind of married together, or they are somehow like they are two but one. But yeah, maybe you can explain a little bit the relationship between you two, like how you work together and what it means for composition, query planning, execution, all of that.
So, sorry, Sergey.
Yeah, just wanted to say, when you see how illusion is built, it's not an illusion anymore, but it's just a joke.
So how it works, how it works with Apollo is that composition runs and you get a supergraph schema. And within that supergraph schema, you have all the encodings for where a type comes from, which subgraph it comes from, other parts like overrides and external and inaccessible and all these sort of things are all encoded within directives within the GraphQL schema itself. So then, I'm not fully aware of the internals, but then the router or the Apollo gateway will then consume that schema and read those encodings from the directives and then do that to plan the queries and whatever. And how WunderGraph does it is that essentially composition does its thing, and whilst it's doing its thing, it builds up a bunch of metadata, and that metadata is then transposed into some JSON. Well, first of all, it's transposed into protobuf and then into a JSON that is read by the or consumed by the router to then help with planning. It's doing very similar stuff to what the Apollo directive encodings are doing. Not exactly the same, but basically you're trying to provide as much information as necessary to actually plan the query from the relevant places in that JSON, just like you're trying to do the same in Apollo with the supergraph with the encodings in the directives, so that essentially you can have a query that or an operation that plans and then ultimately is executed. And that JSON is what we call the router execution config. Because we actually have a router config, which is actual configuration for the router, but then there's this other configuration, which is the kind of the read-only configuration that the router needs to be able to plan. And it was getting a little bit messy with those two terms interchangeably referred to as the router config. So we have the router execution config, the JSON, and then we have the router config, which is the user-defined variables and such that they can change how the behavior of the router, whereas the read-only one is created by composition, read by the router, and then used during operation planning. If Sergey wants to add.
If I remember correctly, when we started out, our composition was very much the same like Apollo. So you have subgraphs, you mesh them together, supergraph in GraphQL SDL. And if this is incorrect, just correct me. But so this was when we started out. And then over time, I remember that you started working more and more closely together, building ties between composition and query planning. And you started moving some logic into query planning, into composition, and you provide this in this structured way that David just explained in the config to the query planner. Can you explain a bit, like you could just do it during query planning, or like why are you doing it this way?
But basically, we always were building a federated graph SDL, like a composed schema, a full big GraphQL schema of all subgraphs. This step still there. We just do not have any additional metadata there, but we always need schema because like your queries will be executed against schema, and actually there is a two versions of this schema because it could be slightly different, but. In our approach, we decided that it will be a bit more simpler to offload some job into the composition, just because composition doing a lot more checks than the planning needs to do, and planning is way more simpler. Like during composition, you have a full graph of all possible fields, all possible types, queries, whatever, to being able to display error messages, to understand like what is possible jumps between subgraphs, what is the relations between them. When you work with this query planning, you know that this query is almost always possible to plan, because we already check at composition time that this query is possible, because composition actually checking that every possible field is possible to resolve. And this called is like a resolvability check or satisfiability check. Like in our case, we just name it resolvability, but it doesn't matter a lot what term to use. Yeah, and as composition has this information, why not to just pass it to the engine side, to the execution configuration, and just make work of the planner and like loading the config much faster and much more simple, because you could gather a lot of metadata and it will be just there, and you could use it easily. The funny part that we don't even always need to read the subgraph GraphQL schemas. Sometimes in the planning, we just read the metadata, because otherwise, anyway, you will need this information to do something. Like, for example, you need information like what is the entity nodes, what is the root query type nodes, like from where you could start the query, from where you can start a query. You need to know is field external or is this field is provided. You need to know like what keys do you have, like and it is possible to do all that when you just load in files, but it will be double work basically, because we already have done every bit of that, almost every bit of that information already was done in the composition. Like, why we would need to replicate it again in the query planning stage if we could just use this data. But the important thing here is that our composition is built with TypeScript and execution engine built in Golang. And it will be a huge investment to build composition in Go or to build execution in TypeScript, and which do not have any sense for us right now. And TypeScript really allows you to iterate very fast. Like I had a previous experience of being Ruby developer, and each time you start a new project, you just bootstrap everything very fast. And during our testing, we always use JavaScript subgraphs, because it is very fast to build some mocks, to build some subgraphs. And it is convenient way. It is not fast to execute that in production, but a lot of our customers still using it. But it works for us. And there was some questions from some of the customers that why we don't use the same format as other gateways doing, but that format is not that useful for us. Like we won't get the same benefits of having this format, because we still will need to process it and to create metadata, and it is more convenient for us to work with not interchangeable format, But in case you use our composition, you just have everything built in, and it works just smooth as is.
Yeah, I personally like to think about query planning a lot. It's a bit like a compiler, and so what you're saying, it's a bit like composition creates compiler hints, and then the compiler can do less work. It can be less complex. The compiler can be simpler. Is that fair?
I'd say as much as possible, because just because of the nature of composition, you have to look at a lot of things to be able to know that something can successfully compose. So you're doing work there. Like, you have to know what's external. You have to know where fields live and how they interact with each other. And the query planner, to some extent, also needs to know what fields are external. So if we can do that work once in composition, and then basically save that result and pass it to the query, you're saving that, doing that work again. You do the work once, and then you share that work, and then nobody has to do the work again because it's already been done. And we basically do that as much as possible, and like you say, offer that in terms of how what's in this JSON, what's in this metadata, to be able to, for the router to consume that, and then eventually by the engine from the router to produce a result basically as efficiently as possible with as little work done twice as possible.
Yeah. So that kind of means if you have a supergraph structure that doesn't contain all this information, you at some point you probably had this information, but you threw it away, and now query planning needs to do it again.
Yeah, you basically will sometimes you anyway will need to read or recreate the structure of the subgraphs, like but when you have just a single schema, you probably will decompose it again into single subgraph to see what is actually available there. You will build these representations of subgraphs probably in a programmatic way, and we kind of doing that, but we mostly just reading this information. And yeah, we still have per subgraph information, and we still have access to the original subgraph schemas, because sometimes you need to see like how it was defined in this particular subgraph. Like sometimes you do not have a direct match on a field. Like for example, you could have interface defined in one subgraph, and all the same field, it will be just a sum of the concrete types of this interface in other subgraph, and it will work. But during the planning, you need to see like, could I just plan this type on this subgraph, or should I just remove this selection set because it doesn't make any sense?
Yeah. One thing that you guys keep talking about, and I keep hearing this, and I kind of find it funny, is you keep talking about jumps, and it kind of reminds me of like science fiction films or something, or a Portal where you do like a jump to something else. Or can you explain a bit like what is your idea behind jumps, and how is that different from how other people think about Federation?
As a consumer of Federation, you just see a single schema, like you fire on the queries, like you have all data in one in one place, and from outside world as a consumer, you just fire in just talking with one single GraphQL API. But underneath you have multiple services, and you could have subgraphs which have root queries and which just do not have root queries. It's only provides some fields to the like it basically contributes fields to the federated schema. Like whenever you have type user, and maybe you have addresses service which provides you with an address. And this is like Federation itself with kind of microservice architecture. And when you design a Federation schemas or Federation subgraph, you typically want to isolate some kind of behavior or some kind of information and move it to its own microservice. But then you need to be able to fetch that data. And Federation standardized this way. Like during my career, I have seen a lot of approaches when you have just one big GraphQL schema which is front facing, and underneath you have a gRPC microservices. And this service with GraphQL, it's actually in its resolvers, it calls gRPC, it calls multiple services and gathers this data. And Federation is just another way of how you could fetch this data between different services. If we will talk about what jump it is, jump is an event when you get all the fields from the current subgraph and you don't have any fields anymore, and you need to fetch the fields from another subgraph. But there is rules for these jumps that basically in Federation we have kind of unique identifiers, and it is called keys. And keys could consist of one or multiple fields, or maybe a set of nested fields. And basically, you need to provide this information to the second subgraph. And when you calculating jumps and composition, there is additional rules applies that you not always will be able to jump to that subgraph. And that is why like a shareable directive exists, because you could share responsibility of resolving this field between different subgraphs. But then to some degree, you could control, like, do you really want to jump to this subgraph, or do you want to jump only from this subgraph? Like, is it could accept inbound connections, or will it be just only outbound jumps? And the most easy way to do that is just to use resolvable false, for example, and it make entity not accepting incoming requests, just because you have no way to resolve an entity from this subgraph. But you could easily jump from this subgraph. And in this case, like, you anyway will have some root query, and this root query, it will be just query mutation or subscription. And this means that your request almost always will start from some particular subgraph. Of course, unless you make this query shareable, but we sometimes think that it's not good approach to make root query field a shareable thing. Like it just splits responsibility between different subgraphs, and yeah, it could be a bit weird to do that, but yeah, it is possible.
Yeah, to add on what Sergey said, like, I like to think of this as that you have an entry node. Every GraphQL API has an entry node, which is going to be your root field. So a query, a mutation, or a subscription. And in Federation, your interface layer is your federated graph. But under the hood, that root field belongs somewhere. It's owned by one subgraph, or perhaps more than one subgraph. And that's your entry node. And then you can think of your lateral jumps to other services as being edges on a graph. So you have your bespoke, you have a subgraph, which is a bespoke graph, but then there are these edges between different services in the shape of shared root fields, shared fields, and entity jumps. And these are the edges that allow you to go from service to service, which is all kind of, I guess, abstracted away. The client and the consumer just see this federated graph, but under the hood, you have all these links in different ways between different subgraphs. And we can kind of refer to those as jumps. These edges between the services are the jumps, and they can be entity jumps, and they can be shared field jumps.
That's one. Sorry, go ahead, Sergey.
Just wanted to mention, like, David just described it there. One main difference between, like, what metadata do we have in composition and what data do we have in query planning. Like, at composition type, you have like a full-blown sub graph. Like, you use graph theory to do that, basically, and you know all entry points, you know all possible connections, you have all these edges. But when you do query planning, you basically have a query, and it's already determined like what is entry point is. And query planning just use tree structure. It's not a graph. It's more like a kind of directed graph, which has layers, and you go layer by layer and see what is possible. Like it's a bit different context of what data do you need and what things are you checking.
You just brought up an interesting thing. You brought up the topic of data structures, directed graph, whatever, and so I didn't study computer science, but I think you too study that. At least I think. Correct me if I'm wrong. But no, they would know. Okay, you're just gambling. It's cool, but just a question, like Sergey, I know you studied computer science at university at least, and probably a lot of us think about like, okay, we go to university, we learn computer science, and we never need this bullshit again. It's just nonsense. But if you think about your work at WunderGraph and query planning, this kind of stuff, do you think you learn something useful at university?
Like it is a bit more hard question. Like I haven't learned the graph theory at university because it's first of all it's sits something in between math and actually programming. It's very involved into math world, and basically I will believe that mathematicians will just definitely learn it in more detailed way than I do that. But about education, you may not learn everything which you need to work, because our area changing is so fast that you always need to be on the top edge and you always learning something new. But it just teaches you about the approaches, about some basements, like maybe some algorithmic approaches, just rather basic one, maybe a couple of programming languages, a bit of QA, a bit of project planning. So it just prepares you to some degree to the real world. But anyway, once you start your first job, it will be whole different world. Like you will need to adopt to approaches accepted in this company, just learn the project. Like even when you're using Git, you just have a lot of approaches how you do the branching, how you do releases, and it's all varies. When I started working, basically we initially we even didn't use Git. We were using what it was. It was SVN, uh, and it is like whole differs from Git. And when I start learning Git, I just was thinking, what it is like, why we need that. Like I was happy with SVN. Like why breaking my workflow? I don't want to do that. But then you start to learn it, and yeah, actually, it's quite useful. It allows you to do a lot of things. Like it allows you to do some kind of magic. It could help you with testing. Like, but I'm not using all features of the Git in day-to-day basics. Like it's the same with education. Like it gives you base some baseline, and probably I think it teaches you how to learn things, and this is the most important thing. Like you just have a lot of time when you learn something, and you just trying to get used to learning something. But what I really enjoy in my work, like it is continuous learning. Like anyway, you learn new tools, you learn new stuff, and with GraphQL, even with GraphQL, with which I work for 5 years, I continuously learn something new, and we continuously improve some old things. And yeah, the funny thing, sometimes I need to learn my own code again. Because yeah, we have written so much of code. It's sometimes hard just to understand, like to keep everything in head.
Yeah. a little bit of a spicy topic. So there is an Apollo Federation subgraph specification that, from my perspective, it's not really a specification, but rather it's more like, hey, here are some directives. And then there's no GraphQL Federation spec. There's a working group that is composed of various vendors that discuss how could such a spec actually look like. But if you look at these Apollo Federation directives, like for me, I can say that like on a high level, GraphQL Federation as a concept, it's a good concept. It allows multiple people to work together, build services. So it's a good concept. But on a technical level, to me, sometimes it looks like these directives were invented, they were created without thinking about the math behind what they do. So there are, and I'm an outsider, so I put this question up for you. But from an outside perspective, it sometimes look like the directives created situations that you cannot really efficiently compute, or you cannot efficiently plan them, or maybe even it's impossible. So how do you think about these directives and how Federation works on the mechanics?
What I could say about Federation, like when you just use it as a consumer or just as a customer who use Federation, you build your subgraphs. It's one separate topic. Like it could be enough information of what you do, but when you use it as a concept overall, and you need to work with this concept from an engineer point of view, it is rather huge. Like it has a lot of moving pieces, like from how you will compose things, what will be the actual results, how it will be executed, and such kind of things, they could not be built right away. Like it is always like some kind of extraction, like Ruby on Rails like was born from the work which was done on some particular project, right? GraphQL was born like from a Facebook approaches, what was convenient from Facebook, and it is always an evolution. So yeah, I strictly believe like Federation always also was an evolution, and you were continuously adding features to it, and sometimes you just stop to see the edge cases, and sometimes you just do not understand already how the things interacts with each other, and it is really hard to test it. But yeah, we're trying to do that.
David, from the perspective of composition, how do you think about this topic?
Jens, are you familiar with Lord of the Rings? Do you at least know what it is?
There's a guy who lost a ring and he searches it.
Yeah, I mean, essentially. So there's one ring which rules them all, right? And I think the problem that you have in composition is that, or with Federation directives in general, is that there's one directive which rules them all. And by that, I mean, you can have, say, 90 different subgraphs. And let's just, for the sake of example, say that each of these 90 subgraphs all define the exact same one set of coordinates that exists in all of them. Let's say it's Sergey.isCool. Let's say that's in every single graph. And the power resides with one person. That one person can add one directive on there, which is inaccessible. And then every single one of the other graphs, all 89 other graphs, are at the mercy of that one graph that has been now written that it's that team has decided, okay, this is inaccessible, and it takes away the responsibility from absolutely everybody else. And you have this disparity of responsibility. You also have it with the shareable directive, which is the shareable directive is trying to solve a real problem, like collaboration between teams, make sure you've got the same data. But once the handshake is completed once, you never have to complete the handshake again. So essentially, you have shareable in one graph, one shareable in the other graph, and then someone else comes in and adds that field, they could return something completely different to everybody else. But because it's already been marked shareable elsewhere, they don't have to have any conversations. So you have this one directive to rule them all, taking away the responsibility from everyone else. So there were good intentions with what these directives are trying to achieve. And again, Inaccessible was designed this way for the sake of migration, so that you could mark something as inaccessible in one place, so you didn't have to do it in every single other graph. But it does mean that you do have like I guess consequences that might not be so apparent from how many graphs and how many teams and how many people you're actually affecting with very small changes. And I think that is one of the I guess one of the problems in how you try to solve a problem, you propose a solution to a problem, and then it's only when you have mass users and enterprises using those features, you actually start to see what should have been done, or what should have been improved. It's essentially tech debt, isn't it? Like it's only after use and iteration you realize what could have been done better. But at that point, you've already got people like that comic that XKCD comic I posted the week. No matter how bizarre your use case is, there's someone somewhere that relies on that for their workflow. So you have to be careful.
Yeah. If you could time travel, go back into the past and be an employee or a founding engineer at Apollo, how would you change Federation? What would you remove, add, or what one thing where you say, oh my God, like it would be better if we didn't have to deal with that?
For me, it would just be trying to make everything as explicit as possible. We're of the opinion that you should, if you have an entity key and you intend to use that to jump to another graph, you should write that entity key in that subgraph. So you have an entity key on the source, you have an entity key on the target, and you have a handshake. You only need to define a target, because as long as you can satisfy that entity key, you can make that jump, that edge between the graph. But what the problem with that is, in the subgraph, so you have a team that owns that subgraph, they might not know that this other subgraph has a key, an entity key that says that it accepts the ID, for example, an ID to be able to jump there. And in their graph, ID is just a normal field. Perhaps it's just marked shareable. It doesn't look like it's doing too much. They think, oh, maybe I can just remove this field because it's not apparently it's not a key, because it's not defined as a key. I'll just get rid of it. And then they get rid of it, and then they realize, oh shoot, like now the composition doesn't work because it says it can't jump to this subgraph, and this was the only route. So you could have completely avoided that problem if you just made everything explicit. Make your intent explicit in the graph. So for me, it's explicitness.
Is this what you call an implicit key?
Yeah, we call this an implicit key. So you define a key field that is not a key field in the subgraph that it's defined, but it's a key field in another subgraph. So there's another subgraph that has a key directive that references that same field. It's just then in that particular subgraph that is the source that's making the jump. It is not a key. It's just a key in another graph. And we call that an implicit key.
And if I'm on the receiving end of the jump and I have this implicit key and I remove it, is that a composition error, or what will happen?
You can't be at receiving end with the implicit key. You need to have explicit key to be able to accept jumps.
Mm-hmm. So the target, so when I say target,
that's what I mean. I mean the target, yeah.
So the target has the key directive, and the key directive has a field set, and the field set references one or a number of different fields. You cannot remove those fields because then it doesn't satisfy the field set defined in that graph. What you can do is from the source graph that doesn't have the key directive, you could just simply remove that, and you're at the mercy of the composition internal satisfiability graph telling you, okay, if you remove this, we can no longer jump from A to B, and that makes such and such a thing impossible. There's a chance that you don't actually need that jump, but another consequence is that while you don't need that jump, you might have changed a single A to B into a bunch of leapfrogging where you've had to go from A to C to D to E to F to G to H, etc., to get to where you actually want to be, which is, say, subgraph B.
And this is what you guys call Lego brick keys?
No, this is what we call leapfrogging. We call
leapfrogging.
Yeah, leapfrogging is where you have a middleman or multiple middleman. I guess middleman is not the right term. Middle graph, where you're visiting that graph just because your route or your destination is one place, but to get there, you have to go down certain roads because there are no other routes to that field. And
the middle graph, it fits into your Lord of the Rings story because it's Middle Earth.
yeah, exactly. Yeah, exactly. Yeah, we have all these internal terms like leapfrogging, and Lego brick keys is another thing which I think we've discussed on this podcast before. I'm not going to go into now, but there are a few things we don't agree with as such. And I think Sergey would actually agree with me that we would just prefer things to be much more explicit. It would prevent a lot of errors on the developer's part and a lot of guesswork on the developer's part if the contract in every single subgraph was made explicit.
Yeah.
Sergey, anything you would change about Federation directives?
Yeah, sometimes you just have allowance of some not so clear behavior, like when you basically could have the same field which returns interface or union in one subgraph, and then you have other subgraph which just returns one single member of the interface or union, and literally it's not even interface or union in that subgraph, and you potentially may even didn't have this definition of the interface or union. You just will have one concrete type. And it is also more about visibility. When you just have type, you don't know like in what union or interface it participates. And it is not from the federated graph level. In federated graph, you will see it. Yeah, right, that I have this type and it implements this interface. But it's a microservice architecture kind, right? You have a lot of teams. One of some of our customers have like 10 maybe to 20 teams which each works on separate subgraphs, and they have to coordinate each time like they collide with each other because yeah, just not that visible when you do some changes that you will affect the other subgraph. But of course it will be catched at composition, but then you need to do your change and to check compatibility, which is like a typical workflow how you work with federation. But yeah, I just believe that this workflow could be better, and it could bring you just a bit more information. Imagine you're just a new developer and you join in the team, but by reading just only subgraph schema, you will see some kind of possible things which you could expect to have in other subgraphs without need to see into huge federated graph schema which could be like 30,000 K of lines, right? Or I don't know the numbers. Like it has no limit. It just depends on your amount of subgraphs and amount of types and fields and so on.
That's a baby graph, Sergey. I think the biggest I've seen is over 100,000.
I think what you two are kind of saying, it's also in the same ballpark of a tweet I saw a while ago from Mark Andre working at Netflix, who like a while ago he said something like, it would be nice if GraphQL Federation had a few less directives and if it was more strict. And I think this is overall kind of similar to what you guys are saying. And yeah. If we talk a little bit about the GraphQL Federation ecosystem, so you guys are participating in the GraphQL working group for the composite schema that's living under the umbrella of the GraphQL Foundation. Maybe you can explain a little bit what is the goal of this working group, and what are the participants trying to achieve?
Yeah,
One standard to rule them all.
Yeah, we are participating for not a long time. We was not there from the beginning, so we just getting to speed up to getting to understand it a bit. But one cool part about it, like the main goal is that you won't need subgraph libraries anymore with this composition spec, because with the Apollo Federation, you basically need to comply with a specific format of subgraph and specific behavior, which is also kind of implicit behavior that is getting added into your GraphQL schema by the subgraph library. Like you get some service fields, some internal fields, which are intended to be used not by user, but by the Federation gateway. It is possible to use it manually in case you know what you're doing, but it is not that friendly. And yeah, one of interesting things it's that really it should make possible to use more regular GraphQL APIs by just instructing the query planner how to fetch data, how to set entry points, how to set keys, and it will allow you to just bypass subgraph libraries. Potentially, you just will need some kind of validation applied to that, but I am even not sure that subgraphs are typically have some kind of validation which are different from the regular GraphQL validation. Usually, you just doing that at composition time with composition checks. And yeah, this is cool concept. But yeah, I just didn't know when it will be adopted, because it has taken a lot of time to adopt GraphQL across the tech world. And then there was some time like from 2019 when the Federation arrived. Do you recall?
Let's say 2018.
Yeah, so like 6-7 years ago, it's appeared, and now it's adopted. And yeah, it's supposed to be an evolution of Federation, but it could take some time to migrate to this approach. And yeah, it's quite interesting to participate and to see what will happen. And it is the same thing basically as with our day-to-day work. It's just interesting to see what influence you could have and how people will use it.
2019, sorry. 2019 was the earliest sort of made public, and then 2020. So it probably existed a bit before that, but yeah, 2019, 2020.
Yeah. One like you mentioned, Sergey, one idea of this new spec is you can just have a regular GraphQL server, and the router will figure out stuff and query planner. But at the same time, if you look at these early designs, one thing that's immediately caught my eye is batching, because I would say the one thing that I have like a love and hate relationship with in Federation is we have this entity _entities field that gets an array of any, which is representations, and we have no clue what that is. It's just JSON. But the good thing about this approach is we have automatic support for batching, as bad as it is, but that's like the upside. If we go away from this approach and we just have like regular GraphQL fields in the root, and we want to batch load entities or something, how will that work?
There is ongoing discussions on that, how it could be done. There is multiple possible options. Like you could just have like kind of batch root fields, like get product and get products, for example. Then another possible way that it will be somehow uploaded to the top level of GraphQL spec. There is some concept of batch execution of variables and queries. And I'm not fully aware of this option. Yeah, but it will just offload some work probably to the execution pipeline that you will need to more carefully plan what you will be doing. And my opinion that you just need to have some kind of batch endpoint, because currently it's a frequent problem even with reference resolvers that you anyway need to have some kind of data loader, even if in subgraph do not have n+1 problem.
Yeah. Okay. Yeah, very, very interesting. Another development we've seen in the community is there are benchmarks and audits that try to benchmark and verify the implementation of GraphQL routers. And I'm curious to hear what you think about benchmarking and auditing and different approaches how to do it, and yeah, just like in general, we do a lot of benchmarking internally, and we do a lot of testing and like what I said earlier, we have a batch query planner that's like a headless router that can build query plans, you can compare them, etc. If you look at this ecosystem and the different ways where other parties try to bring tooling to verify and benchmark, like how do you think about these approaches? And maybe you see some good things about it, but also some drawbacks.
Like benchmarking is always questionable topic, because benchmarks could be biased. Like you could have some kind of a particular conditions under which you will degrade in performance, or you will get high in performance. And sometimes it is not like a feasible to have a one single benchmark for every possible scenario, because there actually with Federation there are like bunch of possible scenarios. You could benchmark just a throughput of your gateway. Just make sure that you are not testing actually throughput of your subgraph, because it also could be a case that just your subgraph is not so fast, right? Then you could sometimes benchmark like a full life cycle of the query, like and it will involve query planning, and you will disable caching of all kinds, for example, right? Just to measure like how fast you could plan a query. And typically you should spend that time on planning just the first time when you reach the query. Then after that it will be cached, and it is like negligible. But at the same time, if your cold query takes like a lot of time to just fetch something for the first time, it also could be a problem. Then it could be a complexity benchmarking, like how fast you will be able to transform some query which requires a lot of transformation. But yeah, all these different parts, it will have influence on the results of benchmark. And just typical benchmark around the gateway, it involves like throughput, like requests per second, and some other data, P95, yeah, something like that. But it is really just a bit more about that in this case. And yeah, you should be just careful when you're creating benchmarks, or I believe we should be careful even if you will be like publishing our own benchmarks, because maybe we could also be biased a bit. Yeah, the second topic, it was about the audit. Yeah, I know in particular what audit you are talking about. It is actually interesting. Like I have also my own opinion about that, and this opinion not related to the audit itself. It is kind of like related to the evolution of Federation itself, and it's everything about the customer experience and customer like way of thinking. Yeah, actually, you do not have a lot of directives in Federation, I believe. I'm not sure which could be safely removed because it's highly adopted right now. But the important thing is that there is hell ton of combinations how you could apply them. And the more subgraphs you have, the more complicated they are. It is much more less predictable, and it is hard to find all these edge cases. But probably it is more simple when you just have a graph and you have some basic set of rules how you interact with that. But it is will be like you just need to implement it right, this graph, and you may not even know how customers will use your like implementation, in which way they will use it. And yeah, this is a problematic. So audits somehow could also be biased, but they are very useful because in case they are done by a third-party company, like who not involved in your approaches, in your relations with customers, it's actually a very good thing because it just whole lot different point of view into this area, and it is useful to have different points of view, and it really could show how you could improve, and you could contribute there, and also improve other solutions. It's kind of some road to have the single spec, but until not all rules are defined, each of the party could try to show the bits of these rules, and you just at least you have some basics to implement something. You try to cover some basic things, and such kind of audits it could help you with that.
Every now and again, we get a question from somebody, like in one of our community places, like Discord or whatever, and they ask us about benchmarks, and typically our answer is the only benchmark you can trust is your own. When you have vendors creating benchmarks, you have to ask yourself, and this includes WunderGraph as well, is a vendor going to deliver something to the public that makes them look bad? And the answer is that obviously no, you're not going to do that. So is a benchmark really capturing the reality of all situations when the real reason a benchmark is created is for marketing purposes? So you have to the only data you can trust is your own. That's my first opinion. And when it comes to things like audits, again, if that's led by a vendor, and the vendor is deciding what is or isn't important to include in said audit, they've decided what is in that audit, what is not in that audit. Federation is a topic that is huge, and the combination of directives and different types of graphs and different ways to write schemas and things mean that you have infinite combinations, and there's not one vendor, Apollo included, anybody who can solve absolutely every single possible thing, because there are endless possibilities, and no one can account for endless possibilities, no matter how good you are. So who decides what is important is one topic. What's important to one company might not be important to another company, and what really is important is what customers want. And every vendor has their own customers, and those customers have issues, and those issues need to be solved, or need to be the solution needs to be reliable. And those are the real kind of benchmarks. Is it working for these customers? Are they able to get their data reliably and safely? Are they able to prevent downtime and whatever else? And there's only so much that an audit is or any benchmark or any audit is always just a lens on a small lens that's focusing on a small section of the bigger picture. That's kind of how I see it. I could, like, anybody here could find any number of things wrong with any other number of vendors. You I could create something that makes, you know, company Y look terrible because I've written that so it make that everything that is in this audit makes that company fail everything. Likewise, I could make it look like I pass everything, whereas I'm not passing things that, as long as you go out of that scope, I'm no longer passing those things. So I would take any benchmark, any audit, anything like that with a grain of salt, and do your own kind of research and benchmarking, and figure out what works for your solution, what works for your company, and whatever else. I think it's important to know that everybody wants to look good. So, you know, you can only trust things so far.
Yeah. One comment from my side, I would say, even if there's no ill intent on the side of someone creating and publishing a benchmark or an audit, I would say there's always bias. Bias in the sense that, I mean, obviously, like, even if we say like, okay, everybody wants to look good, but at the same time, everybody knows the tool best. So I know exactly how to configure WunderGraph Cosmo router, but another vendor who doesn't know it and who actually doesn't care to correctly configure it because they want to look good and they are not deeply interested in perfectly configuring Cosmo router, they will maybe just use defaults and then deploy the whole thing on a machine that is so big that the defaults don't make sense because the defaults are designed for a smaller machine or whatever. It can be any situation, and this can happen to anybody in any direction. Like there are other vendors, they have a gateway written in Node.js. So we know if you want to build something or if you want to get the best performance out of Node.js, it's probably very likely that you deploy a large fleet of gateways on pods with one CPU, because there's no big reason to deploy Node.js on multi-CPU machines, or you add like an extra scheduler and then you run multiple instances. Like you can do things like that, but it adds complexity. So I think there's always this kind of bias that, for example, you like, we know how Cosmo router works, we know what kind of caches it has, and we know how to use these caches efficiently. And so that's one topic. And another topic is, I particularly dislike crafted unrealistic benchmarks, and I explain why. So a benchmark, you can use K6 or whatever, and you can design this benchmark how you like it, and then typically you can do things like ramp up, and then you have like a bunch of queries, and you fire these queries in various ways, and you benchmark the shit out of the router. Okay, so you're hammering the router with traffic, and you get whatever results, and you're like, okay, one benchmark is faster than another. And now you go into production, and in production, something completely different happens. In production, let's say you are a very big e-commerce website and you have billions of requests per day. That means you don't have one router. You have 100 routers, maybe 1,000. I don't know. Like it can be many routers. And so what is the life cycle of a router? From time to time, you need to ramp up the number of routers. Then you scale them down because you have changes in traffic patterns. Like maybe at night, there's less traffic. At day, there's more traffic. So you ramp up, you ramp down. So you have new instances of the router. And then there are situations where someone changes a subgraph. So you publish a new configuration. So now the router needs to invalidate the configuration. And the thing is, in your benchmark, you're assuming that you have one single router and it has a stable config. But that doesn't really matter so much in reality, because in reality, let's say you have 100,000 concurrent users on your e-commerce website, and they are loading the shopping basket or whatever, they want to buy your products, and you invalidate the router config. that means we would now have to query plan all queries on, I don't know, 100 routers. So we would immediately get a spike in CPU and latency, because sometimes query planning can take milliseconds, it can take seconds, sometimes worst case, some queries are very complex to plan. So what you benchmarked in your lab versus what really matters in reality, it can be different things. And this is something it's very hard to capture. And to end this real life story, we had this situation with one very big customer, and as a solution, and I think we're the first in the market to do this, we built a cache warmer that is based on heuristics. So we send information from the router to our analytics warehouse, and then we build like a top list of queries that take a long time to plan and or the worst time to plan. And this top list, we put that in a CDN, and when we start a new router, or when a router gets a new config, we load this top list. We don't yet accept traffic. We load this top list, we warm up the cache, so we plan all queries, we normalize, we do all this. And then we warm up the caches, and once that step is done, we then have it accept traffic. So that means even if you have 100,000 concurrent users, they never hit like a cold router. And now you could say, well, in your lab, you're never actually testing that. So what you're testing is a warm router where all caches are filled. And that's the easy part. But the hard part is we want to continuously evolve our schema. So these are the kind of scenarios where I think, yeah, your benchmarking completely fails. And that's just like from my experience. Think about what you're benchmarking and think about like real life stories and real life scenarios. So that's just my personal take on benchmarking and audits. And yeah, I know we are way over time. Like, but when I watched the clock like half an hour ago, like typically we do this for 1 hour, but I watched the number of participants. We have quite a lot of viewers, actually, more than typically. So it seems to be a topic of interest. So we kept running. We are now getting close to the 1.5 hour mark, and so I want to slowly wrap it up. I have 2 questions for both of you. Number one, I'm curious to hear about like what excites you about the future of GraphQL and Federation, and why do you think people should join WunderGraph on our journey? Why should you join WunderGraph and work here?
Yeah. For the first question, answer is yes. For the second, you should.
Okay, that is typical efficiency on Sergey's end. Yeah, give me a real answer. What excites you about this job, this ecosystem, and why should someone join us?
Yeah, there will be like we always have some ideas, and we sometimes go just from small ideas like this configure subscription directive. It's a rather teeny change. It's not trivial to do inside a composition, but for user perspective, it looks like a rather teeny change, but it solves a lot of problems which you actually could hit. And when you consume API, it's important to have a proper description. When you just use UI, for example, to build your queries and you need the proper docs, it's very important to have it. And yeah, we continuously try to improve quality of life when you are using Federation, and just by having such bits, you could improve a lot gradually. And in case you with us, you will have that things, and it will help you in the future. And we have some other ideas, but yeah, let's keep it secret for now.
David, what's your take? What excites you about the stuff we're currently working on, and why should someone join us?
I mean, I think I've been lucky that in I think every job I've had, I've liked who I've worked with, but I really do like the whole team. I work very closely with Sergey. I work very closely with you. I work closely with a lot of people on the team. I like everybody. We're quite a diverse team. We're spread across lots of different countries, continents, cultures. It's great that we are like all in it together, building something, and we've all, like Sergey, me, Suj, and Nathan have been here from kind of the inception of Cosmo. We've had new people since who are doing a great job as well. And yeah, I never wake up in the morning and think, oh shit, I need to go to work. For me, it's like I wake up in the morning and I'm ready to start doing some stuff, because I really just enjoy being able to develop things and then see directly the consequences of those developments, whether that's breaking something or someone being really happy because everything's working. And regarding joining WunderGraph, like if you enjoy solving sometimes I'd say challenging problems. I mean, because essentially what we do here is that we solve problems. We're a problem-solving company, and we do that by software. But at the crux of it, we're a problem-solving company. And if you like to solve problems, and you like to solve problems that maybe have never been solved before, then by all means, like this is the kind of job for you. If you like seeing the fruits of your labor in terms of what you're actually building, and if you like different perspectives, if you want to not only join the space but actually really set your footprint so you're not just following, you're actually leading the space, I think that is what we want to do here at WunderGraph, and I think we're well on the way to doing that.
Yeah, great insights, and I really appreciate what you shared about Federation, and I think we learned a lot today about query planning, the various directives, the relationship between composition and query planning and all of that. And like from my perspective, I would say what brought me to this ecosystem, I 2018, when I started working on GraphQL Go tools, I was really just interested in working with GraphQL ASTs and transforming them and doing something with it. I thought that was interesting. So that kind of brought me here. And today I see that with everything we have built, we are leaning more and more towards building collaborative tooling. So we enable other developers to collaborate, to build APIs together. We build tooling for teams to work better together and to build great internal APIs. And I think it's a very rewarding thing, because we have the I would say the pleasure to have so many Slack connects with smart people, where we build something, they give us new use cases, we can iterate that, we can make it the tooling better for everybody. People can now collaborate better, and yeah, we're doing that in a very fast-paced loop. And yeah, I don't know, we have great people inside the company, we have great people outside the company, like collaborating with us, working with us, and it's just it's a joy. And I think it's also one thing I would say is, when I didn't study computer science, so I'm a self-taught engineer, and I never thought that I would be able to work in a big company, because who am I? My education, like I'm not on a path where I would be working at an Uber or at an eBay or at a GitHub or Microsoft, because there's smarter people out there and they have the right curriculum to join these companies. But with WunderGraph, and because so many big companies use GraphQL Federation, we are now in a place where we have Slack connects with many such people, and it's super cool. We're now at this level, and we kind of bootstrapped our way there, and yeah, I think it's pretty cool. Like we cannot work there, but we're actually working with them, and I think that's awesome.
Yeah, don't make a blunder. Join WunderGraph.
Okay, I think now it's time that we shut down the stream.
Hey, Jens, you know what the good thing is?
What is the good thing, David?
That I'm not here next week, but you are.
Yes, I am, and Stefan will be back. So, guys, if you like this episode, we don't do this bullshit with like and subscribe. This is not a YouTube channel. This is just
like and subscribe.
Ring that bell to make sure you've got notifications.
No, but I'm really like, honestly, I'm curious. So the last episodes with Stefan, it's typically more on the end of we're talking about everything, and we're kind of business focused more and startup focused. This was very like deep tech. If you are interested in more deep tech, in more deep Federation discussions, tell us over whatever channel you like, and we bring back Sergey and David. I really enjoyed this episode. It was a lot of fun. Thank you guys for joining me today. And yeah, I think that's it. See you.
See you.